That means we have to watch what we're saying now.
And this where the mics are hot. The other thing as we go live, I have to be quick and then turn the speaker off. Okay. So now that this signifies that this is sort of going out to YouTube land. Minimize this. I'll stop sharing my screen because that's that little demonstration is over. Okay, and now I'll be quiet. I won't say anything anymore for the rest of the meeting. And over to you, unless there's any other questions for me.
No, that was great. I'm still a little confused as to why it was that I didn't seem to have the same apps on my
yeah, we'll figure
same capabilities on my version.
Yeah, I'm not sure why either, but that's well, yeah, it's an interesting question. I don't know. I'm not sure the difference.
I'm going to mute now, and I'll come on at the end of the talk, okay?
Perfect. Okay. So we're just waiting for the countdown to 7:30 at this point.
And probably before I got on the call, Heather, you probably tested sharing the screen already, I think.
Yes.
I did, but
sorry for
I can certainly do it on this Zoom if that's helpful. But...
Oh, maybe just in case, please.
Yep.
Probably a good idea.
Looks okay.
Come back to that.
Perfect.
Yeah. Yep.
So Jeff, where was the photo taken behind you? I'm curious.
Oh, this is my grandfather called it the shale pit. It's in Nova Scotia, so it was taken out for highway gravel. It's starting to reforest, so I'd love to see it when it actually gets back to fully treed. So it's taking a while.
Yeah, I was going to say, very shallow soils.
Yeah, it's a gravel. Yeah, it's definitely a gravel pit, but it's really interesting how resilient the conifers and the wire birch are there. So they're making a go of it.
Forest succession in real time. Sounds like. Yeah. You still have family in Nova Scotia then?
Yes, yeah, I've got aunts, uncles, and cousins there, and friends there. So I love to go whenever I can. It's a great place.
It is. Yeah, I've been a couple of times.
Oh, great. But it's been nice. But Ottawa, so my friend is. We used to go snowshoeing, like Rebecca, you were mentioning, and said since he's moved there a few years ago, he's gone snowshoeing maybe 3 times because their snow isn't lasting. Whereas
we don't have that problem in Ottawa.
No, the snow is. I was out snowshoeing on Sunday, so it was quite nice.
I live along the Ottawa River, and there's a whole team of volunteers that groom trails along here for skiing. So I learned a little bit of snowshoe etiquette. Apparently, the snowshoers are supposed to stay on the side of the trail, but around here, there's so many people who use those trails for walking dogs that the skiers end up on the side of the trail. So that's where the better snow is.
Yeah, we have something we call Snowshoe Club, which is really a glorified name for about 2 or 3 people that go snowshoeing along those trails. And yeah, but we're careful not to go in the groomed areas. There's lots of trail grooming for the skiers, but it's a pleasant, usually pleasant trip down around Petrie Island along those trails.
Oh, nice. Yeah. Yeah, I'm up at the other end, in the west end of the river. Just going to check in on our YouTube channel. Numbers are climbing there, so that's great.
It's great. And Rebecca and Heather, once it gets to 7:30, I'll take down this green slide and be ready. You'll be ready to go.
Thanks, Jeff.
Can they see you, or you're?
They can hear, so you might want to close the door, hon. Thanks, darling.
Would you like me to go ahead and share, Rebecca, or do you have a?
Yes, why don't you do that? That would be great. And it's 7:30, so I'm going to officially open the meeting. And I want to welcome all of the folks who are joining us online today. We have a really wonderful presentation this evening by one of the foremost biologists who's working in pollination in North America. We're joined as a speaker by Heather Holm. She is a biologist, a pollinator conservationist, and an award-winning author who has written 4 books about pollinators and of native plants, bees, wasps, and common native bees of the eastern United States. Both the bee book and the wasp book won multiple book awards, including the American Horticultural Society Book Award in 2018 and 2022, respectively. Heather has become a very popular speaker for her expertise. In fact, I think the first time I encountered her was as one of the speakers in the Tending Nature series that was hosted by Ohio State University a couple of years back. And she's also, in addition to being a terrific speaker and an author, she's also a very active volunteer. She's a national honorary director of Wild Ones in the US and serves on the boards of a number of nonprofit organizations. And I found out today she's an Ontario girl originally, now living in Minnesota. So I'm very, very pleased and happy to introduce Heather Holm, who will be talking to us tonight about wasps. Heather, please go ahead.
Thank you, Rebecca. It's a real pleasure to be here tonight. And yeah, as Rebecca said, I longtime resident of Ontario, lived there for the first 30 years of my life. So still have family there as well. So this evening, Rebecca and others the Ottawa Hort Society asked me to present on wasps. And as we were talking before the session started, I'm always pleased to talk about wasps, but I'm never sure whether people are really thrilled to hear that I'm going to be talking about wasps. And of course, the reason being is I would say wasps may be one of the most hated insects by the general public. And that's really unfortunate. So I hope through this presentation that I can show you how valuable they are, the kinds of ecosystem services that they provide us, and why, honestly, why gardeners should really just appreciate wasps. So as you can see on the overview, I'll be talking about a very specific group of wasps. And I just want to emphasize that wasp diversity is now rivaling the number of beetles. So I have some sort of outdated numbers, but these are just to give you some general ideas of how the whole order of Hymenoptera breaks down. So I'm going to start by talking about wasp classification, and then get into the nesting biology and also the similarities between these predatory wasps and maybe our most beloved insect, bees, and then go into all of the plants that wasps like to visit and why, the ecosystem services they're providing, and some sort of drill down to some of what are some of their specific native plant preferences. So which native plants can you plant in your garden that are really attractive to wasps? So wasps belong to the same order, Hymenoptera, that bees and ants and also sawflies and horntails belong to. And you can see the order is broken into two suborders, Symphyta and Apocrita. And I'm just really going to touch on Symphyta to start with. As you can see, again, these numbers were included in the catalog of Hymenoptera back in the late 70s. Many, many more wasp species have been identified and classified, but the order Symphyta has about 1,000 species. And these are really sort of, they're still sort of kind of wasps, very primitive. And you can see their other common name, they're also called wasteless wasps. And the reason being is they really lack that typical highly constricted waist that we associate with wasp bodies. Symphyta includes horntails as well as sawflies. And both of these larvae are plant feeding. The sawflies, as you can see on that bottom right image, look very, very similar to butterfly and moth larvae or caterpillars. And several types of sawflies will feed gregariously like that picture is showing, so many of them together, feeding on often a very specific host plant. The horntails, their larvae tend to feed on wood, so the females drill their egg into a rotting tree or standing dead tree, and then through the aid of fungi, the horntail larvae are consuming wood fiber. So these are all plant feeding type wasps, but very, very primitive. So switching over to the other suborder that I'll be focusing on tonight in the presentation, it includes approximately 17,000 species. And within that, there's really two primary clades. The first one, the parasitic wasps, is probably the most speciose or diverse. And again, those numbers are outdated, but just to give you an idea, close to 10,000 species. And then the clade aculeata has about 7,700 species. And there's really a primary difference between the lifestyles of these two clades, the wasps that belong to them. So the parasitic wasps, here's an example of a very large species. And the females have typically these very long ovipositors. And so this long egg-laying tube that looks like a very scary or menacing stinging apparatus, which it is, but it's pretty uncommon for the parasitic wasps to sting humans. I wouldn't recommend grabbing one in your hand by any means, but really that apparatus is a 2-in-1 apparatus. It's used for not only laying the egg, but also for some venom injection. So that female on the bottom image, you can see how much her abdomen needs to articulate and do some crazy yoga moves in order for her to drill down that ovipositor. And in this picture, she's drilling it through a dead tree and laying it inside the larvae of the horntail. So the parasitic wasps are either laying their egg directly on their prey or actually inside of their prey. So the host that they, once that egg hatches, the wasp larva consumes the host. So these wasps, of course, don't build their own nest. They don't need to. The females spend all of their time using various sensory, smell and sight and so on in order to find their specific host in which to lay an egg. So that's all I'm going to say about parasitic wasps, but there are many, many types of parasitic wasps, but really the focus of sort of the most common flower-associated wasps include the group that are in the clade Aculeata, and that is the stinging wasps. And you can see by the arrangement of this slide, underneath the stinging wasps where the bees belong, and bees are actually the descendants of these stinging or predatory wasps. And the clade Aculeata also includes ants, but I'm not going to be talking about ants today, but ants are, for the most part, sort of wingless types of wasps, but of course have very social lifestyles. So focusing on the stinging wasps and why they are important from a gardening perspective, these types of wasps, most of them do build a nest, unlike the parasitic wasps. And in order to stock their nest with prey, they need to go out and hunt for various types of insects or sometimes spiders. You can see this is a female spider wasp, and she has very recently captured this spider, which she's clasping in her mandibles. And the reason why the spider is basically frozen or immobile is because she has used her modified ovipositor, which is no longer this 2-in-1 apparatus that the parasitic wasps have. Instead, the former egg-laying tube is now just used for stinging, and so a venom injection tool. And solitary wasps sting their prey in order to paralyze their prey. So that spider she has clasped in her mandibles is fully alive, but paralyzed by her venom and unable to move. The social wasps, which I'll elaborate on in some following slides, do something a little bit different. They also have a modified ovipositor, but they are primarily using their sting to defend their nest. So this is the group of wasps that typically humans get stung by. And I'll talk about why that is that they choose to do that versus use their sting to paralyze their prey. So instead of laying their eggs down an ovipositor, instead the eggs are laid from an opening at the end of the abdomen. And this is also the case for bees. So bees, again, being the descendants of this group of wasps, also don't have that 2-in-1 apparatus. So bees, as I mentioned, are the descendants of some of these predatory wasps. Wasps is an ever-changing taxonomic nightmare, I will call it. And more people are researching and studying wasps. So there still will likely be many forthcoming changes in the overall classification of the insects in this order. But for now, let's just go with that notion until we hear otherwise from wasp scientists. So what I find really interesting and why I wrote a book about these flower-associated wasps is their similarities to bees. Because bees are their descendants, really the primary difference between these two groups of insects is the diet. So we know that bees, of course, visit flowering plants because they are either consuming, or if they are a female bee, they would be not only consuming, but collecting both pollen and nectar. So this combination of pollen and nectar is what they are taking back to their nest to feed their offspring. Now, the predatory wasps are carnivorous, and really they're primarily only carnivorous when they're larvae, because their mother is out hunting, in the case of that upper right image, perhaps some caterpillars and stuffing them inside of a prepared brood cell. And that's what the wasp larvae will consume as it develops. But where the flower visitation comes in with these predatory wasps is as adults, and this is true for primarily the solitary wasps, they switch over to primarily a vegetarian diet. And so they're looking for carbohydrate-rich substances, which includes flower nectar. So this is where they're getting their food source to fuel all of their activities. So looking at nesting strategies and the similarities between these bees and the predatory wasps, this is two images stacked on one on top of the other. The top image is of a solitary bee nest, an orchard mason bee, and the bottom is a type of mason wasp nest. I'm pointing out the larvae in each of these images. So the top, you can see the bee larvae are easy to spot. They're all three of them aligned in a row, propped up on their abdomen, and they're busy consuming that combination of pollen and nectar. On the bottom image, the female wasp, the mason wasp, has stuffed each of the brood cells full of various types of caterpillars, and that's what that wasp larva is busy consuming. The provisions, again, the big difference between these two types of insects is the bees are vegetarian and the wasps are carnivorous when they're larvae. And the final similarity that I thought it would be fun to point out, the orchard mason bees are a small minority of native bees that actually use mud to partition and line their nests. So you can see those slightly curved mud partitions that the arrows are pointing to. And the female, in addition to spending a lot of time going out visiting flowers to collect pollen and nectar and depositing that inside of the brood cell, she also sources wet soil, or excuse me, water and soil, and mixes those two ingredients to make mud. And the same for the mason wasp. So that's just another similarity between the nesting strategies. So for the vast majority of both solitary bees and solitary predatory wasps nest in the ground, so between 70 and 80% of all species. The top image is showing a type of willow specialist, a type of bee in the Andrena genus, a mining bee. And you can see that females' pollen collecting structures are loaded down with willow pollen because she only collects pollen from willow flowers. And she likes to nest in really sort of loose, sandy situations. So when that happens, often that nest burrow entrance collapses on itself. So in that upper right image, she's busy sort of pushing her way down through the top layers of the soil in order to find her nest burrow. She'll brush off all of that pollen that she's collected on her structures and then deposit it into a prepared brood cell. The bottom three images are of a type of sand wasp, and similarly like to nest in pretty loose bare sand. And these females exclusively hunt various types of flies. So she's captured a type of flower fly, stung it to paralyze it, flew it back to the nest, clutched underneath her. And then in those bottom two right images, she's busy reopening her nest burrow entrance and then dragging that prey inside. So you can see the strategies of warehousing the food in order to feed the larvae are very, very similar. And in addition to even some of the nest excavation techniques used by bees and wasps. So I'm just going to break down further how the groups within these stinging or hunting wasps. And you can see social wasps make up only 1.5% of the total number of wasps in just this stinging wasp group. So we're not including that very, very diverse clade of the parasitic wasps. And 1.5% is something to keep in mind, because that's a very small number of wasps that are actually, again, using their stinger to sting people or humans or mammals or other organisms that may be a threat to their nest. So the sting, again, is used to defend the nest. So what do social wasps do if they are trying to capture prey, if they're not utilizing that nice tool of paralyzing the prey with their sting? Well, they instead do sort of a pounce and quickly chew up strategy. In that bottom image, paper wasp, she has captured a caterpillar, quickly sort of chewed it up into this mushy mass, and she's preparing in that image to take off and fly it back to the nest. So she will be intercepted by her sisters or nest mates. They will break up that caterpillar into small pieces, and then workers inside the nest will help feed the larvae that are developing within the social nest. The social wasp life cycle is pretty straightforward. There's really a couple of differences depending on the type of social wasp, but the two main groups are paper wasps and yellow jackets. In the spring, the nest is either initiated by one female if it's a yellow jacket, or in the case of paper wasp, the nest can often get initiated or established by multiple females, often sisters. And the first brood or number of offspring that they produce are usually all female, and then followed by a second and third brood that may be all female. But then as we get into the summer months, the females start to also produce males. And that's really when we see a lot of sort of social wasp diversity out in the landscape. The males do spend a lot of time visiting flowering plants to fuel up on some carbohydrates while they're busy looking for a female to mate with. The paper wasps primarily hunt caterpillars, and then the yellow jackets are really true generalists. They'll go out and hunt various types of insects, beetle larvae, caterpillars, you name it, whatever they can get their 6 legs on, they will try bringing that back to the nest. So that flower visitation by social wasps tends to increase as we get into the late summer months. We start to get cool nights, and the females who are next year's queens or nest foundresses prepare to overwinter. And the yellow jackets, whether it's the bulb-faced hornets, the aerial yellow jackets, the ground nesting yellow jackets, the females overwinter by themselves, often going under a rotting log in a forest or woodland. That picture there is showing a female that has found a nice insulated spot in a curled up leaf on the ground. And the paper wasps overwinter in groupings. So several sisters who will be next year's foundresses will find maybe a crack in a large rock or a similar sort of insulated spot where they'll spend the winter before emerging in the spring. Just to note that this sort of social wasp life cycle is almost identical to our native bumblebee life cycle. So just keep that in mind. So what is the nest? How does the nest architecture differ between these two groups of social wasps, the paper wasps and yellow jackets? Well, the paper wasps build a single comb, usually attached to some kind of horizontal object. In natural environments, that might be a rock overhang. In our human-built environments, that may include on our house soffit. But the way to identify a paper wasp nest is it lacks an outer paper nest envelope, and it is only a single comb. So you can easily observe the activity of a paper wasp nest because it's completely exposed and usually facing downward. The yellow jacket wasps in the genus Vespula, for the most part, usually nest below ground in often an abandoned rodent hole. Some of the species in this genus are the most aggressive towards humans, so that's typically the type of wasp that we may get stung by. And they're building nests that have multiple combs underneath the ground, and often including a paper nest envelope for more insulating properties. And then the genus Dolichovespula are the ones that are building these beautiful architectural large conical paper nests way up, often attached to trees. So we often don't even know they're there until the end of the growing season and the leaves fall. And lo and behold, I had one right above my garage one year, and we walked underneath it all summer and didn't even know it was there. But that nest has a series of multiple layers of a nest envelope, and it keeps expanding as the growing season progresses. And inside it, it will contain multiple combs. So in order to create these elaborate architectural paper nests, it requires a lot of time and also searching for various types of fiber. So some paper wasps may use the dry grass stalks in order to create their paper fiber. And the females are using their large mandibles and really just in a chewing mechanism, sort of walking backwards across the substrate, chewing off a thin layer of the fiber, whether it's dry grass or exposed dry wood, and then sort of working that with their mandibles while regurgitating some water to moisten it, and then taking that big glob of sort of future paper back to the nest. And then they will continue working it and working it and working it in order to make elaborate rows of paper strips on the leading edge of the envelope, or more intricate hexagonal shaped paper cells within inside the nest. So both the often the queen, in addition to the workers inside of this social nest, take part in this fiber collection and paper production. All right, so switching over to, I guess, what I would call my favorite sort of group of wasps, of the hunting and nest building wasps, and that includes the solitary wasps, and they make up just over 50% for this overall group of wasps that are nest building. And they have those similarities that I already highlighted with bees. They're either nesting above ground or below ground. And it's very, very uncommon for the solitary wasps to sting a human, usually if someone accidentally picks one up or it flies into you, but it's pretty rare. So they want to reserve all of that precious venom and their stinging apparatus, again, to sting the prey that they're hunting. And the sting can, often the prey will be stung multiple times in order to cause that full paralysis. And that really immobile but still alive prey really makes it much easier for the female who needs to transport it back to the nest. I mentioned that sand wasp earlier, clutching the prey beneath her as she flies with it. But there are a number of predatory wasps that are hunting prey that are often much bigger than them, and they need to transport that prey by dragging it across the ground. So there are different sort of prey transport strategies depending on the size of the wasp and the size of the prey. But what is the benefit of having a brood cell such as the one pictured here, stuffed full of paralyzed caterpillars? Well, when the female wasp lays a single egg on that cache of food, having them paralyzed ensures that the wasp egg, and then when the egg hatches, the wasp larva, really don't get injured while they are feeding on the caterpillars. The other added benefit of the venom and keeping the prey alive is that it remains fresh. So it's really like another completely different form of refrigeration, in a sense that this big pile of prey is still alive and fresh and stays alive in just enough time for the wasp larvae to consume it. All right, solitary wasp habitat. So the habitat of solitary wasps, and this also includes bees, is obviously varied. These wasps have different nesting strategies, whether they're nesting below ground or above ground. The individual wasp species will have specific flower preferences. So some will only visit certain types of flowers, or may only be able to access certain types of flowers to sip on the nectar. The other food that is a primary food source when flowering plants aren't blooming include sap flows from spring sap producing trees such as maple or birch. in addition to honeydew, which is the waste product of plant feeding insects such as aphids. So those are sort of the three sugary primary food sources for a lot of these wasps. And the nesting preferences, some, as I mentioned with that example of both the bee and the wasp nesting in sand, some have very specific types of soil that they're seeking out, and that would be dictated by the landscape and then what flowering plants would actually bloom in those sandy conditions. And some are nesting in cavities and woods, so that can include woodland edges, forests, and in addition, places such as in pithy stems of shrubs. And I'll show an example of that. But you can just imagine the complexity of or mosaic of habitat that these wasps need in order to find the three primary components of their life cycle. So the flowering plants for food, the prey that is perhaps specific to a plant host, and then an ideal place to nest. And so this is an example of a wasp that nests above ground in pithy stems. So here I'm showing a patch of sumac, and this type of mason wasp in the genus Leptochilus likes to nest in pithy stems that you would find if you broke off the end of a sumac branch. And so the females are boring down that pithy center of the sumac stem, making a long linear cavity, similar to what some of our cavity nesting bees would do. She primarily hunts beetles, including weevils, which tend to be bore into various types of tree nuts, in addition to some types of trees. And then nearby, she needs flowering plants. So this particular mason wasp isn't very big in size, so she's not going to fly very far, perhaps 100 or 200 meters at the most from where she is nesting. So all of both the prey and the food sources for her need to be together in close proximity. And in addition to the flower nectar being a primary sugary carbohydrate-rich substance that the wasps seek out, both males and females, to fuel these activities, as I mentioned, they also like to sip on or consume honeydew. So if you see a wasp perched on a flowering plant in your garden, but they're not actually on the flower, they're on the leaf below, they may be consuming some of the honeydew that has dropped from aphids that were perhaps around the flower head of that plant. The social wasps, as they capture and quickly chew up their prey, are often also consuming the hemolymph, or sort of the blood-like fluid of their prey while they're doing so. A minority of wasps will also consume pollen. This is not well understood. It may be incidental, or some may be actually purposefully consuming pollen in addition to nectar when they visit flowers. And then late in summer, when you have fruit, such as crab apples or similar types of fruiting trees, as that fruit falls to the ground, a lot of social wasps in particular are attracted to downfall fruit on the ground. And then the social wasps kind of break all the rules. They are also can be carnivorous as adults, and some will eat dead insects, mammals, dead birds. So they are looking for some protein out of meat sources in addition to some of these sugary carbohydrates, but that is not the case for all the other kinds of wasps. So wasps like to visit flowers, but their flower preferences are quite different from bees. And one of the reasons for that is their anatomy. They don't have tongues of similar or long length as bees do. So that will influence the kinds of flowers that they can quite simply access the nectar from. And then each of these solitary wasps has their own sort of seasonal phenology, where they may be active for three or 4 weeks while they're constructing a nest and provisioning that nest. So it's really what flowering plants overlap with their own seasonal phenology. They are also not going to visit flowering plants that are nectarless. We have a number of flowering plants, native roses, spiderwort, St. John's wort are just some examples of nectarless plants. So you will not see wasps, they may sort of investigate the flower, but you're not going to see them actively consuming the floral resources, which is just pollen. And then, as I mentioned earlier, with those 3 habitat components, the flowering plants obviously need to be in close proximity to where they are nesting, because the females aren't going to fly super far in order to fuel up for their activities. When I wrote the wasp book, I really started to see a lot of patterns in visitation and primary plant families. And these 4 plant families, the carrot family, the aster family, mint, and also the milkweed and dogbane family, are sort of the top plant families that you will find most solitary wasps visiting. And if you think about the flower structure of some of these flowering plants, so the genera that belong to them, the carrot family usually have flat, very shallow, umbel-shaped flowers. So wasps with a short tongue can easily access the nectar from those kinds of flowers. The aster family, which is very diverse, includes things such as goldenrods, asters, tickseed, boneset, and so on, usually have also very shallow open flowers, easy to access the floral resources. The mint family can have a real variability in the flower shape and form. So if you think of wild bergamot or bee balm, that is in the mint family, but the individual flowers have a long tubular flower corolla. So wasps wouldn't generally visit that plant, but there are other mints such as mountain mints and horse mint, which is Monarda punctata, that have very easily accessible flowers. And also milkweeds. So I know we're all trying to plant more milkweeds, of course, for the monarch butterfly, and many to choose from. And I always say there's a milkweed for every garden situation. So be prepared to also bring in some wasps with your milkweeds. So why are wasps important to gardeners? Well, it's really the fact that they are providing 2 critical ecosystem services. The first one, of course, is incidental pollination, because of that flower visitation and probability that they are moving around some pollen from flower to flower of the same species. But this slide is really showing that the really more important ecosystem service they provide. And that is insect pest population control. So what's really fascinating about all of these individual wasp species that are predatory, they each have their own type of insect that they hunt. And that's what this graphic is showing. So one type of wasp may only hunt flies, and that may be just flies from a handful of families. Other wasps exclusively hunt grasshoppers. So you can see how the division of labor of sorts breaks down, in that if we took wasps out of the equation, a lot of these plant damaging or feeding insects their populations would really go awry. So wasps do keep sort of pest insect populations in balance through their specialization and predatory behavior. And that is what's really neat and fascinating to me, is sort of writing my wasp book, I discovered how much prey specificity occurs in these predatory wasps. So it can be quite broad, where a single female species hunts a prey from multiple families. And then it can get really, really narrow, where the female, like this Cerceris halone, is only hunting weevils that belong to a single genus. And so these weevils I'm talking about the bottom left image here. So that female only hunts weevils that bore into acorns. So her habitat is obviously tied to where oak trees grow, because that's where her host occurs. And she has that real strict or narrow specialization on a type of beetle, a weevil that bores into acorns. Some specializations can be a little broader. The 5-spotted spider wasp, for example, hunts spiders from several families. And we also have types of wasps that hunt bees. So they're still beneficial and important in the circle of life. And some of them specialize primarily on bees in the sweat bee family, Halictidae. And how does this prey specificity play out on the ground, whether it's in this park in the picture I'm showing or in our gardens? Well, it's pretty interesting because they all have their own essentially food sources that they're seeking out to provision their nests. And this is no exaggeration. This graphic that I have here on top of the photo, each of these various wasp genera were all nesting in this bare compacted footpath in the park. And the reason they do so, and this commonly occurs, is one, it's ideal soil nest type. So they all like to nest in compacted sand. And then secondly, each of these wasps are hunting a completely different type of prey, whether it's plant bugs, flies, bees, ants. I'm going around the circle here. Also, you get the drift. They're all hunting out into the landscape and looking for different insects from the wasp nesting next to them. So they can all get along and really capitalize on these ideal conditions. What do wasps' ground nests look like? Well, they look very similar in sometimes to bee nests, where the female is excavating all of that soil within the nest, depositing it around the nest entrance. So that upper right image of the beetle wasp or sorceress nest looks pretty similar to a bee nest. You know, bee nests sometimes have a little bit more tight soil mound or tumulus. A lot of wasps that nest in sort of well-drained soils will dig and excavate and push that soil out to one side. So that's, you know, really what I'd call a lopsided tumulus. And then others are really crafty. They don't want natural enemies to find their nests. So some will even pick up mounds of soil, fly away from the nest excavation area, and then drop the soil elsewhere. So it helps conceal the whereabouts of their nest. So inside each of these nests, usually the female will create multiple brood cells. And then within each of those brood cells, she'll usually stock it with multiple prey that she has stung, paralyzed, and carried back to her nest. So here's an example of a ground nesting solitary wasp, the great golden digger wasp, probably one of the most recognizable wasps that visit flowering plants in gardens. And the nest architecture of this wasp is very similar to bees. So it has a sort of a main burrow that the female excavates, and then laterally branching off from that main burrow, she excavates these individual brood cells. So these females stock each individual brood cell with anywhere from 2 to 6 true crickets or katydids. And this is an example where the prey is often bigger than the female wasp. So you can see she's perched on the ground, straddling the prey in that bottom right image. And she will have to maybe try and fly with it, but ultimately probably walk it or drag it across the ground and then pull it down her nest burrow. So it's really the weight of the prey can dictate how far away that they may be able to even hunt for their prey, because it's such a effort and energy expenditure to go too far and then having to walk it back across the ground. The smaller or medium-sized wasps, however, tend to carry their prey clutched underneath them so they can fly with it. And that is the case with this American sand wasp that hunts various types of flies. The nesting strategy of this wasp I'm highlighting is a little different from the other solitary wasp. So this particular wasp progressively provisions its nest. Most wasps mass provision, meaning they go out and they hunt a handful of prey, stuff all those prey in the nest, lay a single egg, close the nest cell up, and then repeat. Whereas the sand wasp instead creates a single nest burrow and goes out and hunts for the first fly, puts it in the nest, and lays an egg on it. And then she leaves the nest open. And over the following days, she sticks her head inside to see how the larvae, if the larvae has consumed the first fly that she's put in there or not. And when it's out of food, she will come and bring it another fly. So this is the progressive provisioning. What's unusual from a sociality standpoint is usually in the case of solitary bees or wasps, the mom they never see their offspring, or for that matter, the egg hatch or their offspring develop into adulthood or have that interaction. So the sand wasp is doing this a little bit of sort of wasp larva interaction, which is unusual. And the reason being is because mom is progressively provisioning the nest cell. The eastern cicada killer is an example of a specialist. So they specialize on hunting cicadas. This is the largest size solitary wasp in eastern North America. Really scary looking for people who don't understand wasps. The females dig these absolutely huge burrows. People often mistaken them for rodent burrows because of the quantity of soil that she piles outside of the burrow entrance, in addition to the size of the opening of the nest. And the reason is she hunts dog day cicadas, and they are really large true bugs. And she needs to fly up in the tree canopy, sting that cicada, and then somehow try and launch from the tree, fly as far as she can, but that cicada weighs often 2 times as much as she does. She'll often crash to the ground, rest for a while, try another flight sequence, eventually getting it back to this giant burrow that she has created. And the reason the burrow opening is so large is because she needs to have enough room for it to drag down that really big cicada that she has captured. So this is an example where she only needs to capture 1 cicada, and only 1 would go in a cell, because the cicada is so big, it's plenty enough food for her larvae to consume as it develops. All right, so talking about the rest of the wasps, approximately 20% that nest above ground, and very similar nesting strategies to native bees. They are often looking for some kind of pre-existing cavity. Here's a picture of a mason wasp nest with the larva in the top image, and then the pupal stage, so that the pupa is starting to look like an adult wasp. It will get sort of coloration on its integument eventually, finish its development, and then emerge as an adult. And these pre-existing cavities can include places like woodland edges, woodlands, places where there are holes in standing dead trees, logs lying on the ground. The sumac stems are similar soft-wooded shrub species that have opportunities for boring a cavity inside of a stem. A number of species will nest on the ground. So if you have a garden and access to a log, it's a great way to provide some passive habitat, not only for some of these solitary wasps, but a number of solitary bees will also nest in dry, rotting wood on the ground. They tend to reutilize holes that maybe have been created where beetle larvae have developed, and then as they emerge into adults, they bore their way out and leaving a hole or cavity. So those holes or cavities get reused by either the solitary wasps or solitary bees. Similarly, standing dead trees. So holes made by beetles as the adults bore it out of their larval nest inside. And these are just amazing opportunities for solitary wasps to come along and utilize as nesting cavities. So the Actemnius, for example, is a fly hunting wasp that nests in wood, and some other mason wasp, and also potter wasp, very tiny wasps that hunt aphids will also nest in small cavities in wood. So if you have opportunities, a larger property, a way to maybe just have a partial tree snag in your yard, you'll be providing some good habitat. We also have wasps that don't like holes in wood. They are really their own different kind of architect, but they make their own free-form mud nest. And this is a wasp in the genus Eumenes. They're called potter wasps. This particular genus makes really intricate jug-shaped mud nests. So you can see this photo, the upper left photo, the mud is still moist. The female is putting the finishing touches on that flared opening. In the upper right image, she's inserting her abdomen inside of the opening. So the pot is empty at this point. She lays her egg first inside of the empty pot, suspended from the roof of the pot. And then she goes about hunting small inchworm type caterpillars, stuffing them into the opening to fill up the pot. And once the pot is full, she'll seal that opening off with mud. So she will repeat the process, often making multiple nests attached to the same plant stem or the same plant leaf. So if they're really hard to spot, but if you do find one, it's a joy to watch this nest building in action. So in order for mud, it's much similar to the paper making strategy of the social wasps. The potter and mason wasps need a really good supply of bare sand or bare soil. They tend to have specific soil preferences. Some like sand, and they'll combine the sand with their saliva to harden it and make a hard substrate. Whereas others will be seeking out maybe loamy or silty soils, mixing water in with that, sort of forming this moist bolus of mud in their mandibles, and then carrying clump by clump back to the nest, creating those mud partitions inside of the nest and also sealing the nest off with mud. So it's a lot of extra work to have a free-form mud nest, in addition to hunting for a very specific type of prey and finding all the food for your larvae and food for yourself. So, but why these females do it, nobody knows. Here's an example of a mason wasp that nests on hard surfaces. So a small divot or crevice in a rock is a very attractive place. And she tends to make sort of mud cylinders lined up one after the other. That picture on the left, she's done her work for the day, and she's going to spend the night in a partially complete open cylinder. So she's poked her head out to say goodnight to me when I took the picture. But she'll make multiple mud cylinder shaped cells one after the other, and then layer that whole thing with many, many layers of mud when she's all done with her business. Oops, sorry, I forgot I had a video there. I'm going to skip that from a streaming standpoint. And then we have wasps that sort of skip that two-step process. They don't do the water collection and then the soil collection and mix the two together. These black and yellow mud dauber wasps instead really look for sort of silty, moist soil, often next to creeks. And so she's a smart wasp. She sort of skips that step. And then collects in her mandibles large clumps of the moist mud. And what's really cool is many wasps use a vibratory mechanism, which is sort of vibrating their muscles in the back of their thorax at a high frequency. And it's a similar mechanism that native bees use to buzz pollinate plants. So some plants require buzz pollination. They may have pollen producing anthers that are inverted and have small pores or valves. So a bee literally has to shake pollen from the flower like salt from a salt shaker. And native wasps use this similar vibratory mechanism for mud collection. Even when they're applying a big ball of mud to the leading edge of their mud nest, they will vibrate it to help settle the mud, much like a human mason would do. And some of the ground nesting wasps will use this vibratory mechanism as they're excavating. They'll clasp hold of the soil, vibrate their thoracic muscles, and that helps loosen the soil so they're better able to excavate the nest. This particular wasp hunts spiders, and it will make free-form mud nests, often actually attached to sort of outbuildings, sheds, and so on, but sometimes their nest can be hard to spot. All right, I'm just going to mention these last two categories, and then we'll move into sort of things to think about from a gardening perspective if you're now interested in attracting some of these amazing wasps. So the other category includes cuckoo wasps. And they essentially also do not build their own nest. They monitor the nest of their prey. It could be another wasp species or sometimes a bee. They enter the nest while the host is away and then lay their egg inside of a prepared brood cell. So if their host is a wasp, the cuckoo wasp larva will eat the prey that the wasp has provided for its own offspring. If the host is a bee, the wasp larvae will hatch, but wait until the bee larvae gets to its later growth stage or instar stage. And it will not eat the pollen provisions because it's carnivorous, so it will actually eat that late instar bee larvae instead. So you see these really emerald blue or green wasps sort of hanging out around nests, investigating stuff, visiting flowers. You may think they may be a type of sweat bee, but they look a little bit different, and you're probably on to them. It's a type of cuckoo wasp. And then finally, there are wasps called parasitoids in this group of hunting and stinging wasps. They do also have that modified ovipositor, not the 2-in-1 apparatus. Females often will lay their egg on or inside of their prey, similar to a parasitic wasp. This is a female thinid wasp, and she hunts scarab beetle larvae, including white grubs that are inhabiting below ground. So she will hunt for those usually in the evening using smell and sort of tactile strategies, dig down to the beetle grub below the soil, lay her egg on it, and then come back up to the soil surface and leave her wasp larva to consume that beetle larvae. So they can also be beneficial for many root system eating type scarab beetles that develop below ground. All right, so thinking about how can we sort of bring in some of these amazing and sort of beneficial wasps to our garden? Well, we have to think about all of those habitat needs, and it can get complex quickly if you think that they all have individual types of prey that they're hunting, and that may influence where they choose to nest, in addition to their type of soil. But where we can start is really thinking about how we can amplify or diversify our gardens to include more native plants. We do know that the native plants themselves, in some cases, especially the woody plants, may be hosting some of the insects that the wasps want to hunt. And we know that wasps really like native plants for their nectar. So providing a good variety and diversity, and thinking about having, and this is true for all pollinator gardens, having something in bloom from early spring all the way through to late fall. We also have to think about plant arrangement. So getting away from buying really large containerized 1-gallon perennials and planting them 18 inches on center and waiting until those plants mature and may touch each other. So that's kind of the old school way of planting. The newer way of planting is thinking about this palette as a living or green mulch, meaning that plants are growing in a community of various types of plants. They're planted more densely. The way to do that economically is either grow plants from seed or buy them on small plugs. And then you get more bang for your buck. You can really start to fill in these spaces. It really makes life easier as a gardener too, because in that picture there, my garden along my garage, very low weed pressure, right? I'm passing over that garden, looking at it, observing pollinators, and there isn't a single thing in that planting that I need to weed out because it's so dense. A weed seed doesn't have enough light to germinate in that dense planting. And we do know that it just makes life easier for some of the insects that want to live in this type of situation. Beneficial insects can find good overwintering habitat. Pollinators are can easily find the variety of flowering plants in a densely planted landscape. But you can also think about it from a planting arrangement standpoint. So generally planting groupings of the same plant. So a good rule of thumb is odd numbers, starting with 5 or 7 of the same plant, planting 5 or 7 coneflowers for in this picture as an example, and then repeating that pattern throughout the landscape. These larger clumps of like flowering plants make it visually easier for a bee or a wasp flying by to see it, and easier for them to hone in on the floral resources if they are a bee, or on the nectar if they are a wasp. So keeping their energy expenditure lower, it really helps to save energy so that they can find all the food sources for their offspring and do all that other really fun stuff to produce the next generation of bees or wasps. And then thinking of our garden as really habitat. So gardens no longer can be just pretty and sort of plastic and static. Gardens should be dynamic. Gardens should change over time. Garden plants should move around in the garden. That's okay. Allow things to happen, and you learn from where plants really want to be. In some cases, maybe you planted a plant in the wrong place, and then you realize it really likes this different situation that I have in my garden. And mimicking Mother Nature. So can we think about how we can incorporate things such as logs lying on the ground? That upper right picture is stem stubbles, a strategy I recommend for native bees. You cut the old flower stalks and leave the stubble, and that provides nesting opportunities for specifically some of our smaller native bee species. And the green mulch strategy. So thinking about how you can spend more time enjoying the pollinators in your garden versus doing gardening. I love gardening, but I also like not doing a whole lot of gardening anymore, and enjoying my garden instead. So thank you so much for tuning in on YouTube this evening. It was a pleasure to present on wasps, and I'd be happy to take any questions if we have time.
Hi, Heather. I'm Julianne, and I'm a member of the Ottawa Hort Society. I wanted to just thank you so very much for that wealth of information. I learned so much, and wasps, I think, are not always the favorite insect in the garden. So you really helped to turn my head around in terms of rethinking that relationship with wasps. I'm going to be monitoring questions in our chat, and hopefully we'll have some time for questions. But in the meantime, I just wanted to thank you for some of the things I learned from your talk, including how we as gardeners should really be rethinking wasps and welcoming them, because they are, as you said, they're incidental pollinators, and they really make such a difference in terms of insect and pest control. I also learned from you that we really, again, how many times do we hear that need to add more native plants and to garden densely, and to basically think of our gardens not just as a place of beauty, but habitat for all living things. So thank you very much for that. I do have a question that relates to a personal experience that I had, because you mentioned that you had a wasp nest on your garage and you didn't really notice it. Well, the same thing happened to me, and I fretted about it, not knowing quite what to do. And I felt really badly in the end that we knocked that hornet's nest off because I was afraid someone was going to get attacked. I'm wondering, how do you deal with wasps that pose a threat for gardeners or homeowners?
Yeah, it's really, I like to characterize it as situational. So, the social wasps, which are more likely to sting us, their nests are sort of starting with one or a couple of females, and then as the growing season progresses, you're getting more and more offspring produced and more nest occupants. And so those nests tend to get what I'd call more dangerous at the end of the growing season, so late summer. And I can say each year in my home garden, I have at least 1 or 2 ground nesting yellow jacket nests. And I often, just through observation and walking through the garden, see, again, in that late summer, July, August timeframe, I start to see all of a sudden this activity of wasp, coming in and out of the nest. And I note to myself, okay, I have a yellow jacket nest in my garden. It's ways away from any human traffic on the walkway. I tell my husband, we've got a wasp nest, don't go in that area. And I just let the nest do its thing because it's really far enough away that I know it's not going to pose a threat. And again, all of those nests are annual. So as soon as we get those cold temperatures, where you are in Ottawa or where I am in Minnesota, the wasp activity declines quickly, and all of the occupants eventually die once it gets cold enough. So I often wait it out, but I do this assessment of first being very observant to notice the nest, determining whether it's too close to humans or not. And most of the time I just say, oh, I can let that one go, just make sure everybody knows it's there and we don't walk across it. So that is my strategy. But then we have the time and place where we don't know the wasp nest is there, and we accidentally mow it, over it, or we walk on it and we get stung, and it's in a high traffic place. Then you may want to intervene if you are concerned that other people will get stung. One strategy that my neighbor uses frequently is she will put a bucket over the nest entrance for ground nesting wasps, and then weight it down with a large brick or stone, wait a week or so, and that usually will sort of starve the occupants inside the nest, and the nest is then no longer active. So that's a non-chemical solution.
I'm wondering if there are any other questions. I'm not seeing any in the chat function. And I'm also seeing that we're actually running a little bit over at this point. So unless there are any further questions, I'm just going to thank you again so much for joining us. And I really hope you come back and talk to us again. There's so much to learn on this topic.
There is, and we actually do have a couple of questions. One of our very active volunteers, Tula, had a couple. One question was about, and you may have answered this, Heather, but do wasps ever attack other wasps?
Yes. Yeah, there's the wasp attacking bees and the wasps attacking wasps. So that prey specificity includes wasps that hunt other wasps. So they don't differentiate with their own kind.
Okay. And she had a really interesting question, actually a bee question, if you don't mind. She had a leafcutter bee nesting in a large planter. And one morning the soil had been dug up and there were bits of the nest scattered all around. So she was wondering what would have done that?
Oh, that could have been a raccoon, or, depending, usually it's raccoons. They often dig up ground nesting wasp nests, but they will also be attracted to any kind of insect larvae. So that, I suspect that's what may have happened with the leafcutter nest in the pot. I mean, squirrels will dig up soil in pots just for fun, right? And see what, especially if you just planted something. But if they went after the larvae, it was probably a raccoon.
Okay. And I had a question too, because I was intrigued by your reference that the venom will last to paralyze the prey long enough for the larva to feed on it. Mm-hmm. And, yeah. Maybe I'm thinking of solitary bees that, where the larvae develop over the winter. So how long does that venom last?
Oh, so the venom lasts to keep the prey, the food prey, the insect that's been stung, maybe a week to 12 days. That's typically how long a wasp larva, after the egg hatches, the larva is going through 5 growth stages, but that feeding happens in a very short period of time. So within a week and a half. So the prey that venom doesn't need to keep the prey alive super long, because then they go into their next stage of development. They either spin a silken cocoon and sit there in a pre-pupal stage, or spin that cocoon and continue on with their pupal development. So it depends really on the wasp phenology. So if, a wasp that is active in the spring, they may produce multiple generations. So that development from egg to adult is very short because the next generation of adults is out foraging in the landscape. Whereas if they produce one generation per year, that larval development is fairly quick, but then they sit in that pre-pupal or pupal stage for quite some time. Could be over the winter in diapause, and then the development sort of gets restarted in the spring. So that's
yeah. Really, really fascinating. One last question, if I may, and this is from Lynn Patenode, who observed an underground nest at the back door of their cottage.
okay.
And watching a constant stream of wasps flying high up into the trees. She was wondering what they might have been doing. I'm wondering, that sounds like it might have been the cicada wasps that you were talking about.
Yeah, if it was like a lot of coming and going from a single nest hole, then that's definitely a social wasp. So that is a clear visual cue that you've got a social wasp nest. If they're heading up to a tree, they may have been seeking out honeydew. There may have been aphids up feeding on the foliage, creating honeydew. They could have had a good prey source up in the canopy. So there could, it's either going to be food or prey that would likely have created that high-speed traffic pattern to one spot.
Fantastic, thank you. I think that's it for our questions, Julianne.
So again, I'll thank you, Heather, and say good night, everyone, and thanks for listening. Have a good evening.